All right, in this video, I'm going to derive the quadratic formula. So what we have on the screen here is a very generic quadratic equation, right? Which is coefficients a, b, and c. And I'm going to complete the square on this generic equation. So the way we complete the square, remember, is to divide every term by the leading coefficient. When I'm finished with that, I'll end up having x squared plus b over a times x plus c over a is equal to 0. Then the next step of the process is to kick the constant over to the other side. So we'll have x squared then plus b over ax is equal to negative c over a, because the sign will change when it crosses the line. Then we're supposed to take half of the b term and square it, right? So let's write that over here. Half of b over a will simply be b over a times 1/2, and then we need to square that. Well, that's going to end up giving you b over 2a, and if you square that, you're going to end up with b squared over 4a squared. Now, remember, that is going to be added to both sides of the equation, so we'll end up having plus b squared over 4a squared, and then plus b squared over 4a squared on the right as well. Now this trinomial can be factored. It's going to be a perfect squared trinomial, and the way it factors is x, and then because it's a positive on the right, it'll be 2 plus signs in the factoring, so we'll just put a plus there. And then remember, it's basically this piece that goes inside the parenthesis there. So it'll be b over 2a, or in other words, half of the original b term, so b over 2a. Now from there, that'll be equal to, we can clean that up just a little bit, so we can write it as a fraction with a common denominator, so that's going to be something over 4a squared, right? Now how do I get this fraction to have a denominator of 4a squared? Well, if you think about it, I had to multiply the bottom by 4a, so I'll have to multiply the top by 4a, so it'll be minus 4ac plus the b squared from here, right? Okay, good. Now at this point, we can apply the square root property to both sides of the equation. So I'm going to take the square root of x plus b over 2a quantity squared, and that'll be equal to plus or minus the square root of this fraction. I'm going to put the b squared first, minus 4ac all over 4a squared. I put the b squared first because it's positive, that's all. All right, from there, the square root and the square cancel out, and we're left with x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. I'm separating the radicals there because the denominator can be simplified. So this will give us x plus b over 2a is equal to plus or minus the top part, b squared minus 4ac all over 2a. Because the square root of 4 is 2, and the square root of a squared is just a, right? And then finally, we finish this problem by saying that x is equal to, so I'm going to move this b over 2a over here across the equal sign, which makes it negative. So it'll be negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then you can just write that as a single fraction because they have common denominators. So it'll be 2a in the bottom, and it'll be negative b plus or minus the square root of b squared minus 4ac. And there you have it. There's your quadratic formula. All it comes from is using the complete the square approach on a generic quadratic equation. This is why both the complete the square method and the quadratic formula work for every quadratic.